I think I'm going to a little bit speed up to cover the topic before you start your second project, which is required for the chapter 10, 11, and 12. So for your better understanding, I'm going to a little bit speed up. So last class we talked about the hardware part of I/O, so especially the hard disk drive as well as the solid state disk. So right now you probably understand what is the hard disk drive and what's the benefit and what is the solid state disk and what is the advantage and disadvantage. Due to the characteristic of the solid state disk is nothing but the memory actually. So which means if we know the address, so we can access the data. So which means we don't have to worry about such the latency a lot. It's almost a zero latency, which means we don't have to worry about the physical hardware performance. That is the main problem of the hard disk drive. So a couple of years ago, the people believed if the price of the solid state disk dropped a lot, then the solid state disk will replace most of the part of the hard disk drive. But currently, both the HDD and SSD are used a lot. So each of them has their own characteristic. Like the hard disk drive is much cheaper than the SSD, and their speed is quite still the catch-up, the speed of the SSD. So nowadays, bottleneck is not a problem of the hard disk drive, the latency. Instead, it's the other part of the computer component will be the bottleneck. So I believe for a while, both the hard disk drive and the solid state will be used together. For example, the portable devices such as a cell phone or a tablet use the SSD definitely because of the size of the dimension of the solid state disk and your device. On the other hand, the hard disk drive is much cheaper than the SSD, so it can be still used for the laptop or the other personal computer or the storage device. So we will see that today, based on that idea, it's not the problem on the SSD because SSD does not use any hardware, the mechanical operation. However, the hard disk drive has the disk current, as we discussed last time. So basically the media is the platter, like the CD-ROM. Okay. So then we have the track, and then the same track of the set of we have the number of the platter that we call the cylinder. So when you see the hard disk drive the capacity, you need to check the number of the cylinder. Okay. Then we divide the it's a track. It's not the sector. This is called the track. The same position of the track along the number of platter is called the cylinder. So this is a cylinder. So outside the cylinder number 0 and inside the nucleus. Then the track is divided by the number of partitions. Each partition is called the sector. So we have the number of sectors inside, but the problem is that each sector has a different size depending on the location of that. So to address that problem, logically we are going to define the new data structure on top. So these are the hardware structure, but on top of that we define from the same size of the block from the outside and inside block number 0, 1, 2. This is called the logical block addressing. So from the operating system point of view, we are going to use this block number. Then if the operating system requests or any other component in your computer requests to read the data from the hard disk drive, and there's a controller. There are a number of different controllers that we discussed, CASI and SATA and PCI, the ICE, CASI. There are a lot. Among them, we will use one of them. Then the controller knows how to convert such a request. The logical address of we will discuss a little bit more for the next chapter. Next chapter, I think, regarding to the addressing format. It's the hardware addressing or the logical or the physical addressing of the such a storage. But this one convert such a logical address of the data to the physical address. Finally, read the data. To read the data, since we have the number of the cylinder and it's a track, So there's a disk arm like this one. This one is moving forward and backward. It's actually left and right, but there's a moving forward. There's a head, so head can read the data. Nothing but 0 or 1, but this one is moving forward and backward. However, if data is here, this one should rotate. Then the speed of the rotation is called RPM, the number of rotation per minute. Nowadays, I think it's around 15,000. So 15,000 is the high speed of the rotation. So this is called the rotational latency. So there might be something delayed to read the data, even though the header is positioned. So that is called the rotational latency. Plus, this one is moving left and right, forward and backward. That is called the offset at seek time. So total, the hard disk drive has such a delay of the time, seek time plus latency. So when we read the data, depending on there might be a lot of requests to the disk controller. So this controller manages, as we discussed before, each I/O device manages what? The queue to schedule to process the requested. So it has the number of the requests to read the data depending on for example, one is here, first request, another one is here, second is here. So if you back and forth, it will take a longer time. Okay? So if we have the number of requests here, we try to speed up to read the data. So that is called the disk scheduling. So disk scheduling actually done by this one, or sometimes the operating system can take care. Have you ever heard about the long time ago? It's maybe the 15 to 20 years ago. So there's a personal computer like the multimedia, the personal computer, multimedia PC, or the similar name. So those operating systems actually focus on to read the data, very large video data, and also compress and decompress like the JPEG and the MPEG file, the encoding and decoding, plus the disk scheduling, because read the data, like the video data, may be different from the read the data for the file. So just the text file. So it has a different disk scheduling. So to read such a video data, so at the time you can use such a disk scheduling. Nowadays, but here, however, this latency, rotational latency, is comparing to the seek time. The seek time moving left and right is very low, okay, because it rotates around 50 to 60 per second, even the rotate. So sometimes when we schedule the disk scheduling, we ignore this part, the rotational latency. Instead, we just check the seek time latency. So at seek time, to schedule. So our goal is to minimize the seek time. So we will see quickly. It's not very complicated. It's very straightforward to design the disk scheduling algorithm. So our goal is here disk scheduling is to minimize the seek time. Okay, we ignore such a rotational latency. Comparing to the seek time, the rotational latency is very low. Then to measure the seek time, so we can measure the word clock, but usually in computer system we to measure the performance. The word clock time is not very well. Instead, we are going to use a different measure to for the performance. In this case, the time to find the data along the track is the same. It's proportional to the what? It's a distance, moving distance. If the header is moving a lot, it will take a longer time. If the header moving is shorter, then it will be shorter. So when we design such a disk scheduling, instead of measuring the time, so we can just calculate the distance of what? The header movement. How long, how much the header is moving. So we can change the problem of the disk scheduling as the minimize the seek distance of the moving header. So we will see such a different schedule. to do that, for example, we had since we assume that we do not consider the rotational latency, we can simplify the problem. We cut this slice this way, then cylinder number 0 to for better understanding, because we are familiar with the 0 to left. So cylinder number 0, then cylinder number, for example, 200 divided by 199. Okay, so this is actually like this one. Okay, but since we ignore the rotational latency, so it's just a cut slice one side. So then we can present the 0 to 199 cylinder, for example. Then this header is moving forward and backward and such a way. So we try to find the algorithm scheduling that minimize the total moving distance. Okay. So for example, if the controller has a request of the 100 and 150 and 199, the 100 here and read the data, and 150, 199. So the total moving distance is this much. We can add. Then we can compare with the other algorithm, which one is a shorter distance. That will be the better performance. In case we have the 100 and 0, 199, it will be like the 100 come back, and then the 199. It will be longer, the moving distance. So if we wait, then if we consider the growth just the moving the one way, something like that. That's the idea of the disk scheduling. So what will be the first algorithm that we can expect? Yeah, always first come, first serve. So which is a simple, but it's a reasonable and easy to implement. Sometimes it's a best performance. So first come and fair. So to do that, we are going to, just like the process state, we are going to use the request. This is the demo simulation of the request queue. So we have the 0 to 199. Suppose that the cylinder, 200 cylinder, the hard disk drive, and then right now, how many? 1, 2, 3, 4, 8. The I/O request. First one is in the 98. Second is 183. Third one is 37, and so on. It's a cylinder number. However, since we ignore the rotational latency, this is just the slice of the disk drive. So if we can present it this way, the lower number, the left hand side, higher number, cylinder, the right hand side. So this is a request. So header point means, so right now the header is like the 53 position. Like the 53. This is the tip of the header, so you can read tip of the arm, so you can read the data. It's currently 53. Then first come first serve is a simple. We can just read the data. 98, then 183, then next 37, and so on. That's it. It's a very simple algorithm. Like this one is to demonstrate. So currently the header position is a 53, starting from the 53. Next one is 98, and next 183, followed by the 37. The header is going backward. And next one is 122, 14, 124, 65, 63. This is an illustration of the trajectory of header. Okay. In real situation, it's like this one. Okay. Then I illustrate the trajectory of the head of your arm. Okay. Then to measure the seek time, we are going to consider the seek distance, total amount of the distance, moving distance, which means we can add up from 53 to 98 and add up this amount and this amount, until here. So this is the total seek time, seek movement. So if you sum up, how much is that? 640. Why don't you add up all of this? It will be 640. Okay, question?
So we determined the number 53. Head starts at 53 by dividing 640 by the total number of Q.
Any question? The other? Any question? Okay, yes, go ahead.
So we determined the head starts at 53 by
Yes.
using the number 640 divided by the number of Qs.
Yes, so number of the Q, we have the 98, 183 in this order. Okay, then read the data first, 98. So header need to move the little bit, right? So to the 98, and the next to read the next request, 183, and move to the 183. So header is moving. Okay, then the next one is the 37, backward, and so on. So we can add up all the trajectory of the blue one. Okay, that will be 640. It's just a simple algorithm. So first come, first serve. Okay. Any question? No. Then, do you think that it's the efficient way? Probably not. So think about the elevator. So if you take the elevator here, the UV, you may not realize that's just the situation, but in the downtown, so sometimes you crazy, the elevator is going up and down, never. Right? So what most of the elevator use what? First, the lobby is the most the frequent access the floor. So going to the lobby, then going up to the top, then going down, going up. In case there's the button, there's anyone who would like to take the elevator, then stop and take it. So that will be another one is the elevator algorithm before that. So another algorithm we can consider is from this request. The current position is 53. Instead of following the first come first serve, why don't we take the nearest one? Okay. So which one is nearby? The 53.
65.
65 is the nearest one. 65 or 65. And read among the requests in the queue, find the nearest one, shortest path, shortest one. So read the 65. Then from the 65, which one is the nearest one? So that is called the shortest seek time first. Similar as a short, what is the shortest remaining job first in the CPU scheduling? Quite similar. So we'd like to read the data from the queue among the requests in the queue. That is the nearby, the shortest, the seek time. So then it will be like this. So if you sum up all this trajectory, the moving distance, it will be 236. Okay. However, when you calculate this one, please try whenever my son is Nicholas. He is the 8th grade, 7th grade sometimes. So 7th grade, most of the parents believe their child as genius, okay? But when they got the low grade, it's probably mistake, right? So it's not problem of the understanding, it's a mistake. So my wife always said the math grade is always the problem of whether there is a mistake or not. But I believe that if you do the mistake frequently, that will be your lever. Right? So anyway, but I mentioned because the major was the mathematics education, so I'd like to be a math teacher. I believe solving the math problem is simplification. So which means that you can, for example, when you solve the problem of the equation, this is called if you have the 2x plus 4 is equal to 5. How do you solve this one? Isolation. Right? So isolation means we try to, somebody may get the what is x directly, okay? But most of people not. We try to isolate. Isolate means simplify. The coefficient of x is better. the 1x. Then we know what is the x. Then to do that, we can actually solving the equation has most of the important thing of the mathematical algebra. Like it's the axiom like you can both side the operation like the -4 minus whatever that is. But anyway, solving the problem, the best way is the simplification. The fraction is the same, so the factoring is the same, it's all the simplification. So do not try to difficult way. So sometimes solving the problem is like find the path or the direction. There are a lot of different directions to go back to home, but you'd better use the fast and the easy way to avoid any accident or the unexpected. So to solve this problem is the same thing. So you can add up all the piece of the trajectory, but probably higher chance to be mistake. Instead, you can add up to the 53 to 67, 1, and 67 to the 14, 2, 14 to the 183, 3. So you can add up only the 3 parts. You can be smart. Okay? Because whenever I ask the similar or the same question to the student, really half of the student mistake plus in the plus and minus. Really. Even though they are using the calculator, it's not a problem of the using calculator. So even sometimes you push the wrong buttons, please simplify. Then calculate the total distance. Anyway, in this case, the total distance is 236. Comparing to this one, which one is better? This one is faster. So this is the shortest 6 times first problem.
How do you know like which is the near one? You have to see.
You need to calculate.
Yeah.
That's the overhead. So which means you need to, whenever you select the next one, you need to sort this data. It takes some time. Sorting usually the biggest problem in any computer science algorithm, computer architecture algorithm, or data structure. So another problem is starvation problem. This is not a dynamic change, but in case of the real application, there might be incoming the request. So if you just read the data like around here, then if there's any other request further, there might be no chance to read such a data. So it may have the starvation problem, like the elevator. When you take the elevator, if somebody keep pushing the button nearby the elevator, the car, so you may not have a chance. You need to wait a longer time. So to address that problem, we have the scan algorithm. That is exactly same as the elevator, the problem. So from lobby to top floor and up and down, up and down. If there's any request, read it. So in other words, in real the implementation, this cone is moving. It's like the windshield wiper. So it's moving this way. If there's any request, you will read the data. That is the scan algorithm. For example, using the same request. So, but this time you need to know what is the direction of the header. So for example, whether this one is moving this way or this way. In this case, it's moving the downward. So the lower cylinder number. Suppose that. So from 53, suppose that it's moving the downward. Then read the data, 37, 14, and 0 is because we do not know whether there is a data to be read in case of dynamic incoming. So we read the disk arm, disk head is touching the lower, the 0, then upward. And up to where? In case there are the request 199 and down 0 and the end and down. So keep back and forth, back and forth. This is the scan algorithm, elevator algorithm. Okay, the total moving distance 6 times. 6 times you can measure 53 to 0 plus 0 to 183. Do not calculate each piece. It will be disaster. Okay. please do not calculate each end. So please be smart. If you understand the algorithm, you can easily get the total moving distance. So 53, 0, 0 to 183. So this is a scan. Problem? We have to touch it. In case there are a lot of in the middle, so on. So we don't have to touch it, the 0 or the top. Instead, the loop algorithm use the C-scan. Not C-scan. Loop algorithm is the same as the scan. Scan actually from 0 to the 199. However, loop is the lower cylinder number to the maximum cylinder number. In this case, 53 to 14, then 183. Not touch the 0 and the largest number. So there's no loop here. So this is in this case, the loop is like the 0, 199. So starting from the 53, then next 37, next the 14, and next instead of 0, it will be 65, 67, and eventually 183. So look, you can sum up the 53 to 53 minus 14 plus 183 minus 14. This is the total, the moving distance of the loop algorithm. So scan and the loop are the same except whether you touch the 0 and the highest cylinder number or not. That's the only difference. Then another problem of the scan and the loop is which one has the higher chance to be accessed, in the middle or side. So this column is moving this way. So I realized that when I like to play the tennis, so sometimes 3, sometimes 4. Some of the coach toss the ball. So there are 3 players. Then it's a clinic practice. So feed on the ball, first, second, and third. Then not going back, and next, middle. Then the first, second, third, second, first, second, third. So which means the middle will have higher chance, better chance to get the ball, right? Because it's back and forth, back and forth. So in this case, when you read the data such as elevator or the loop or the scan algorithm, the middle part have the higher chance than the side. So it's not fair. So to address that problem, we can address that problem once you read the data and move. Which means you read the data this way and going to the end. Then read the data only one way. So one way read. So that is the C-scan algorithm. So C-scan is, so you read, let's say the disk header is always moving down to the lower to higher cylinder number. When the disk arm is moving to, in this case the 0 cylinder number is outside, the higher, 0 to the 199. At the time you read the data. Once you read the data, then going back to the initial position 0. Then read the data and going back, and read going back. So that is the C-scan. So the difference between the scan and C-scan is one way or two way. Scan is a two way, C-scan is one way. Loop is the same. Loop, the difference between scan and loop is whether loop and this one. So loop, there is a C loop. So C loop is you can read the data only one way up to what? Highest cylinder number. Then going back to lowest cylinder number request. Okay? Then that is the C loop. So scan and the loop, the difference between the scan and loop is whether the touch the beginning and end of the cylinder. And the scan and the C-scan is the two-way, C-scan is one-way. And the loop and C loop is a two-way, not touch the both sides. And C loop is the see, look, is the one way, but not touch the both sides. So these are the possible the disk scheduling algorithm. Which one is the last one among the disk algorithm? C-scan? The fastest one is actually shortest seek time first because it tried to minimize. The problem of that the shortest seek time is starvation. So to address that starvation, most of the operating system use the combination hybrid of that. So basic algorithm is the shortest seek time first, but usually we can address the problem of the starvation by elevating the priority. Here the priority is which one is the nearest one, right? So we can consider if not accessed a certain time, we can use apply the scan or the C-scan algorithm. From time to time, the disk arm is moving, the end of your cylinder number and going back, then apply the shortest seek time and so on. So it's a combination, usually the combination of that. Okay?
Professor,
Yes?
what is the difference? I didn't understand like the difference between C-scan and scan.
Scan, the scan is the scan. If you see the C, means there's a one way. So you read the data only one way, then going back, and read the data going back. So for example, I toss the board to the student this way, then going back again, toss the board this way. Now back and forth. If I going back and forth, only the middle student, the student in the middle got the higher chance, right? So that is only the difference. The difference between scan and look is the scan actually 0 to n. Look is lowest cylinder number to highest cylinder number. Okay, that is the only difference. Calculation is just add up, but a lot the mistake. Okay, so please practice at least one time. Then you can easily understand the algorithm. We are not going to implement this. For the implementation, it's not a big deal. So if we have the Q, then we can calculate the performance, decide, implement the scheduling algorithm, then decide which one is the next. Okay, then so far in this chapter we talk about the mostly hardware part. Okay, mostly hardware part. The next part is later we will talk about the formatting. Okay, but here this is called the low-level formatting. So for example, so here a lot of sensitive data. So I don't want to give let the other know the policeman would write the forensic of the disk. So I'd write the formatting or the initializing the device again. Then what happened, do you think, when you format the hard disk drive? What does it mean actually formatting? So we learned about the hardware structure of the disk drive or the, what is that? The SSD, okay? Then when you format, what happened? It's initialize everything. So you expect that your data, sensitive data, is deleted? What do you think? Please don't make any crime.